लेट आएगा अपने आप ज्वाइन कर लेगा. Yes, children. So chapter circles. It's a very easy chapter. You will love it. There are just two properties, or you can say two theorems in the chapter, based on which only one exercise is there. Now the two properties or theorem, whatever you call them, are a part of your syllabus. So you have two theorems from triangles and two theorems from circles, which are going to be there in your syllabus. Now to start with the chapter, I would like you to do some exercise. What is that exercise? At the back of the register or anywhere. Suppose I am giving you one bangle. मैंने आपको एक bangle दे दी. Why I am saying bangle? Because it is circular. ठीक है? And I am giving you one line. Mind it, I am saying line. I am not saying line segment. So all of you have a circle and a line with you. Play with it. ये आपका सर्कल है, ये आपकी लाइन है. प्ले विद इट. आप जैसे मर्जी दोनों को प्लेस करो. एंड आई वांट यू टू डू दिस राइट नाउ. हरी अप एंड शो मी योर पेपर. वीडियो ऑन करके शो मी योर पेपर एज वेल. इफ यू डोंट डू दिस एक्टिविटी, यू विल नॉट बी एबल टू गिव अ गुड स्टार्ट टू द चैप्टर. हरी अप.
मैम कर दिया.
शो मी ऑन योर स्क्रीन. वीडियो ऑन करो और शो मी.
कर
आज
दिया.
I'm not asking you to turn on your media because you are saying network issues. नहीं तो मैं पढ़ाऊंगी नहीं बिना उसके. Okay. Yes. Anybody else who has done that? और किसी ने? Please, I'm waiting. Hurry up.
Yes, ma'am, मैंने किया.
But I am not able to see. Okay, fine. Who else? Play with the line and circle. Hurry up. Others, please switch on your video and show it to me. You are getting recorded. Hurry up.
मैंने भी किया.
ठीक है, since not many of you are showing, whoever has shown, I will start.
मैंने भी किया.
Some of you have placed it like this. Now I am not mentioning, even if you have put it like this, both mean same to me. I'm not worried about the angle. Okay? Some have placed like this, that is, there is no contact between a circle and a line. Here you can see the line is meeting circle at 2 points. And some of you have drawn like this. Yes? Here the line is touching the circle at 1 point. No point, 2 points, 1 point. So here both of these are separate entities. This line, I am not calling line segment beta. Line segment is called chord or diameter. This line, which is touching the circle at 2 points, is called secant. And this line, which touches the circle exactly at 1 point, is called tangent line. We call it a tangent line. Right? And in your class 10 syllabus, we are going to do about tangent. Secant was there when I was in class 10, but now it has been removed. So in your RD Sharma or RS Agarwal, you may be finding questions on secant because they have not deleted the previous portion. So you need not do it. You only have to take care of tangent where the line is touching the circle only at 1 point. Secant questions you don't have to do. Clear? So how do we define a tangent? How do we define a tangent? We define tangent as a line. We define tangent as a line which touches the circle only at 1 point. Which touches the circle only at 1 point. Okay? So if XY is a line, O is the center, P is a point where tangent touches the circle, then this line is called tangent line. This line is called tangent line. Okay? And this P is called point of contact. This P is called point of contact. As the name says, the point where the line, tangent line, is making contact with the circle. Children, are you with me?
Yes, ma'am.
Yes,
Yes, ma'am.
ma'am.
Now, suppose you take any point. Suppose you have a point, let's say X. X is a point and you are joining OX. Now this X is known as external point, external or exterior. You may call it external, you may call it exterior. Okay? Something outside the circle. Now the distance between this external point to the point of contact, the distance between external point to the point of contact, that is XP, is known as length of tangent. This is known as length of tangent. Clear, children? So I have given you three terms now. Three terms. Let us recall those three terms. And those three terms are tangent line. We define it as a line. Mind it, children, it's a line, can be extended. A line which intersects circle only at one point. Only at one point. Point of contact. Point of contact is the point where circle and tangent line meet. That is a point of intersection. Length of tangent. As the name says, length, lambai. So distance between the external point and the point of contact is known as length of tangent.
मैम
Yes, beta.
मैम हम लेंथ ऑफ टेंजेंट एक्स वाई क्यों नहीं मानते?
Beta, tangent stops at P. You can also call it YP as a length of tangent if you join YP. YO. So YP भी length of tangent मान सकते हो. It's your wish. You check from left hand or you check from right hand. ठीक है?
मैं मेरी लेंथ ऑफ टेंजेंट समझ नहीं आ रही.
Length of tangent in simply, I'll draw you. See beta, you have a circle. This is the point of contact. Whichever external point is there, either from the left side, right side, anywhere, whichever external point is there, the distance between this external fixed point कह लो, exterior point कह लो, whichever. The distance from this point till the point of contact. Distance from this point till the point of contact is known as length of tangent. Simple. आप
मैम
कोई
ये
भी
एक्स वाई पे कहीं पे भी हो सकता है.
if you take point here, if you take point A here, then this distance AP, जो भी आपका है, this will also be length of tangent. External point से point of contact के बीच का distance. ठीक है?
ओके मैम.
Now suppose I'm giving you the two properties. Based on those two properties, the entire chapter has to be done. कुछ और है ही नहीं chapter में. And what are those two properties? This first property is that the line segment, understand, line segment joining center of a circle. एक second बेटा. the line segment, I'm saying line segment, joining center of a circle to the point of contact. This one. क्या बोलते हैं हम इसको circle में? Whenever a line
Radius.
segment
Called
radius.
radius. Sorry.
We call it radius. So the first property is radius is perpendicular to the tangent. Radius is perpendicular to tangent. This is your theorem 1. And we have to prove it also. And it can be asked in your exams. It can be asked in your exams as well. Now, how are we going to prove it? That radius is perpendicular. But आप मुझे एक चीज बताइए. What is the shortest distance between any two things called? Which
Line
distance is the
segment.
shortest distance? Are which one? Suppose you are all are sitting in a room right now. If you have to measure the distance between the roof and the floor of your room, which distance do you calculate?
Perpendicular distance.
Perpendicular. And that is the shortest distance.
Yes, ma'am.
We, for example, square. We call this as the edge of the square, the length of the square. We never said that
Yes.
diagonal is the length of the square. है ना? So, shortest distance between any two things is nothing but perpendicular distance. Is this clear? Children, are you clear with this? The
Yes,
shortest
ma'am.
distance?
Yes.
Yes. What we are going to do is, we are going to show that here, this OP is the shortest distance of all. हम ये show करेंगे, this OP is shortest distance. And being the shortest distance, it will be perpendicular. अब आप एक general knowledge की चीज बताइए मुझे. This is a circle. This is center. This distance OP is radius. If I take any point A inside the circle, will OA be equal to R, less than R, or greater than R?
Ma'am,
Less than R.
That is smaller than radius. If I take any point B here, OB will be greater than R, smaller than R, equal to R.
Greater than R.
Greater than R.
If I take any point right here, let's say C, बिल्कुल boundary से थोड़ा सा बाहर है, मैं zoom कर देती हूँ आपको. Can you see? It is not on the boundary, but little bit outside the boundary. Now, will OC be greater than R or smaller than R?
Greater than R.
So we all know any point outside the boundary will be greater than R. ठीक है ना? Now see, I am taking a point here. Let's say here. Any name I am giving. OM. Is OM greater than R, smaller than R?
Greater than R.
Greater than R.
Greater.
OM and OP. Which one is smaller?
OP.
OP.
OP छोटा है OM से. If I take any point, let's say N here, and join OM, N is outside the circle. So
Yes.
what is the relation between O and OP?
Ma'am, OP is smaller than ON.
OP is smaller than.
ठीक है?
is smaller than ON.
मैम समझ नहीं आया जो आपने अभी बताया.
M और N सर्कल के बाहर है, अंदर है? They are outside or inside?
Outside.
So any point which is outside will be greater than radius, na? If you join it to the center.
Yes.
So OP, OM, ON सबसे छोटा कौन है? OP. If I take another point, let's say here T, and join OT, T is still outside if you zoom. Zoom करके देखो T भी बाहर है ना, क्योंकि ये तो एक ही point पे touch कर रहा है यहाँ पे. So any point here is outside the circle on this line. So OT is also less than OP. Right? And likewise, if I take any point here, let's say Q, what about OQ?
OQ is also greater than OP.
right? So you take any point on this line other than P. That point will be lying outside. That point will
Yes.
be lying outside the circle. And lying outside means it will be greater than radius. So which is the shortest distance here?
OP.
OP. And we know the shortest distance between a point and line is nothing but perpendicular distance. That the shortest distance between a point and a line is nothing but the perpendicular distance. So OP is perpendicular XY. So OP is perpendicular XY. Yes, children. And this will be more clear to you if with the help of a compass, you draw a circle and you draw a tangent line with the help of a scale. You will find that the same are intersecting at one point, and that will be lying on the line, but they will be outside the circle. They will be outside the circle. मैं आपको और neatly बना के दिखाती हूँ. Actually, my pen tip is little broader. तो जो आप छोटी सी टिप से बनाओगे तो आपको अच्छे से समझ आएगा. And also, this is not a perfect circle. See, it will be touching only at one point. Rest any point you take on the line. The point is on the line but outside the circle. Zoom करके दिखा रही हूँ. Can you see? The points are on the line, but they are not touching the circle. And if they are not touching the circle, means they are outside. If they will be joined to the center, it will be greater than R. So OP is going to be the smallest of all. OP is going to be the smallest of all. Children, please tell me if you are getting it or not.
Getting it, ma'am.
Yes,
Yes, that is how we
Yes,
are
ma'am.
proving the first theorem. We have to prove first theorem this way only. I will be giving you in writing, don't worry. That the first theorem says that the radius is perpendicular to tangent through the point of contact. Through the point of contact. We have to
Ma'am?
mention point of contact. Yes, beta.
मैम जो OPA सबसे शॉर्टेस्ट डिस्टेंस है पॉइंट ऑफ कांटेक्ट और सेंटर ऑफ सर्कल के बीच में मैम इसको हम सिंपल ऐसे ही प्रूव करेंगे कि सारे जो पॉइंट्स हम ड्रॉ कर रहे हैं और जिन्हें हम ज्वाइन
Yes.
कर रहे हैं वो आउटसाइड द
Yes.
सर्कल है.
Yes, yes. We are going to prove it like this only, that they are outside. Being outside means they are greater than radius. And so comparing all this, we get OP is the shortest distance. And the shortest distance between any two things is nothing but the perpendicular distance. And therefore radius is perpendicular to tangent. So there is no particular language. You can write in your own language also. But we have to give these reasons only. Okay, beta? Yes, children?
Yes,
ma'am.
yes, ma'am.
Yes, ma'am.
Very easy. So this is the first result that will be used in the question. And now I'm telling you the second result, वो तो इससे भी ज़्यादा easy है. And using these two results, we shall be doing the chapter. Second result says, before doing second result, let us understand one thing. Suppose this is a circle with center O. And let us say there is an external point P. A, कुछ भी बोल दो. Let us say A. From this external point, how many tangents can you draw to the circle? कितने कर पाओगे? Infinity.
Infinity.
Because a
One.
tangent has to be perpendicular. So एक straight line बनेगी आपकी. ये बनी एक straight line.
Yes, ma'am.
और कहाँ बनेगी? ये तो infinity तो तब होगा ना
नीचे की
जब
side.
और एक यहाँ बनेगा. ऐसे ही बनाना है आपको स्केल से, जैसे मैं बना रही हूँ. This is my scale. Wherever it is touching, that is another point of contact. Can you draw more?
Yes, ma'am.
Can this,
No,
can this be a tangent?
मैम
Can this
लेकिन
be a
अगर हम इसको घुमा दे
मैम
तो
हम इस साइड दूसरी साइड पे तो
क्या
बना ही सकते हैं।
मैम जैसे ए
सर्कल?
वाली साइड जो ए के सामने
सर्कल?
साइड।
अरे बेटा वो तो मैं एक और पॉइंट ले लूं, यहाँ से दो और बना दूंगी. My question is from a fixed point, how many can be drawn? From a fixed point.
टू
मैम तो दो
मैम
ही हो
टू.
सकते हैं।
Oh,
मैम
ना?
अगर फिक्स
From a
पॉइंट
fixed
ना हो
point
तो फिर कितने?
to infinite.
Infinite.
From any point you can draw. See, circle is a collection of infinite points. See this. Circle is a collection of from this point, one tangent. Next point, one tangent. So ऐसे तो करते करते you can draw infinite tangents. Infinite tangents can be drawn to a circle. But from a fixed external point, how many tangents can be drawn at a time?
Two.
Two. Yourself. Right. And two tangents are drawn. The length of tangent is AP, and here the length of tangent will be
AQ.
AQ.
AP and AQ are the length of tangents. We have to show that when the tangents are being drawn from the same external point, then they are equal in length. So this is the second property which says that AP is equal to AQ. This we have to show that AP is equal to AQ. Is second theorem and it is very easy. You have to do one construction. You join OA, you join OP and OQ. Now using property 1, what is OQ and AQ? What angle is it? We have done radius is
Perpendicular distance.
90 degree. What about
Yes.
OP and A?
90
Right.
90 degree.
OA is equal to OA. Why?
कॉमन
What
common
about
radius
OP
equal
and OQ?
radius
इक्वल रेडियस है।
Radius of a
So,
circle.
so are these two
RHS.
triangles congruent?
yes
बाय
ma'am.
आरएचएस।
Yes, ma'am.
And listen, now if two triangles are congruent, will AP be equal to AQ?
Yes,
Yes,
ma'am. CPCT.
Why?
सीपीसीटी।
By CPCT.
Are we done?
यस
Yes, ma'am.
मैम
Yes.
एक
हाँ
चीज
जी.
पूछनी है।
Yes,
एक्सरसाइज
प्रियंका.
कौन सी है?
ये theorem है बेटा.
ओके
This is theorem. I've not started with any exercise. This is theorem. I said there are two theorems. First theorem says radius is perpendicular to tangent, and second theorem says from an external point the two tangents drawn are equal in length. So these are the two results based on which the entire chapter has to be done. Getting my point?
यस मैम।
So बस और कुछ है ही नहीं chapter में, so you can get to know that how easy the chapter is. We just have these two properties. Based on these two properties, we have to do 8-10 questions. Right? Now, children, one thing I want to ask you. Just now we have shown that these two triangles are congruent. Okay? Using that thing, can I say that angle 1 is equal to angle 2?
यस मैम बाय
Yes,
सीपीसीटी।
ma'am.
yes
Why?
ma'am.
सीपीसीटी।
By CPCT.
Okay? Can I call this AM as an angle bisector of angle A?
Yes, ma'am.
yes ma'am.
Can I say that AM bisects angle A?
yes ma'am.
Yes, ma'am.
Does it also mean that the angle bisector? Now, what is angle A? There is a term for angle A. This is called angle between two tangents. This angle is known as angle between two tangents. है ना, ये दो tangents के बीच में angle ही तो है ना. This is your AP, this is your AQ. इन दोनों के बीच का angle ही है. So can I say that AM bisects angle between two tangents?
Yes, ma'am.
I have just changed the name बेटा, है ना? और अब मैं AM को ये लिख सकती हूँ that the angle bisector lies on the center, passes through the center.
Yes,
बोलो.
ma'am.
The angle bisector passes through the center. So this also you
Yes,
have to
ma'am.
keep in mind. So this you have to keep in mind that the center lies on the bisector of angle between two tangents. This center is lying on the bisector of the angle between two tangents. ठीक है? ठीक है?
Yes, ma'am.
Children,
Yes,
it's
ma'am.
time for your next class. Please stop recording.